Welcome, everybody. So today we're going to talk a little bit about three-dimensional vectors and the cross product. We haven't done a lot with three-dimensional vectors so far in the physics course, so this is somewhat new. In 3 dimensions, we're going to need a couple of new symbols because it's kind of hard to draw 3D perspective vectors. So to represent vectors that point in and out of the page, we're going to use a symbol which is a circle with a dot on it. For vectors that point out of the page, so they would be coming out of the screen at you in this instance, and that vectors into the page have a circle with a little X through it. And a good way to remember that is you can think about an arrow in flight, which if it's coming at you, you see the tip of the arrow, and if it's moving away from you, you see the fletchings on the back of the arrow. So that's a good way to remember that notation. Once we've got that notation down, the thing that we're going to do here is learn a new way to multiply 2 vectors together. And that new way is called the cross product. Now, we've already learned about the dot product in Physics 211, but this is a new way to multiply 2 vectors together that you may have seen in a math class. It is called the cross product because we will represent it by writing the 2 vectors with a x in between. The dot product had a little dot in between. And what's interesting about the cross product is that the result of the cross product is a second vector, which was very different than what the dot product is. There are some rules that the cross product will follow. The first one is that the result of the cross product will always be perpendicular to the original 2 vectors. So if you have one vector that points this way, and one vector that points this way, the resulting vector must point either up or down. Because those are the only directions which are perpendicular to the original 2 vectors. Furthermore, you can figure out the magnitude of the vector given by the cross product by multiplying the magnitudes of the original vectors times the sine of the angle in between the vectors. And you can see a geometric representation of this down here at the bottom of the screen. Here are my vectors A and B. And if you want to get the magnitude of the resulting cross product between A and B, you would take the magnitude of A and then multiply it by B times the sine of theta, which is actually the part of vector B, which is perpendicular to A. So basically, cross products are all about perpendicularity.